Alright, this is the washer method. This is going to be my second example. We're going to talk about taking a graph and revolving it about a line or an axis and finding the volume. So the volume is pi times the integral a to b of big R x squared, big R of x squared minus little r of x squared. Okay, and the big R of x, that's the upper radius or the outer radius, depending on if you're revolving it about a horizontal axis or a vertical axis, and little r is the inner radius or the lower radius. Okay, and that's really all you have to find is big R and little r, square each of them, and subtract, and then integrate. Okay, so let's take a look at the second example. It says find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared and g of x equal 1 about the line y equals 1. Alright, so first let's draw a graph. Alright, so let's see, there's 1, there's 2. Okay, so I'm going to space this out a little more. Okay, so first let's graph g of x equal 1. And that's the line, that's also the line y equals 1. Okay, so there's g of x. And then let's graph f of x. Well, we know this is a parabola. The vertex is here at 2. Okay, at 0, 2. And we know it's a parabola that opens down because of the negative sign. And so if we draw the graph, it's going to look something like this. And we'll stop. I know it keeps going, but we'll stop here at the line y equals 1 because that's the line we're revolving it around. Okay, that's the line we're revolving it around. All right, so now I need to figure out my limits of integration. I'm going to integrate from what to what? Well, we need to know, when does this curve intersect this line? Okay, so when does 2 minus x squared intersect the line y equals 1? So I'm going to set these two equal. So I have 2 minus x squared equals 1, and then I just solve for x. So I get negative x squared equals negative 1, x squared equals positive 1, so x is equal to plus or minus 1. Okay, so we know this is negative 1 and this is positive 1. Okay, now let's draw our rectangle. And when you're doing the washer method, the rectangle is going to be drawn perpendicular to the line that you're revolving it around. Okay, so here's our rectangle, and that thickness is delta x, so I know I'm going to be integrating with respect to x. Alright, so now I need my outer radius or upper radius, and that's going to be this radius here. That's big R of x. Okay, and remember, the radius is the distance from the line that you're revolving it around. It's not going to be from the x-axis here. See, this is the x-axis. It's not measured from that. It's measured from the line we're revolving it around. All right, so what I do know is that to this point here, okay, to the outer radius, I know from the x-axis, okay, I know this total distance here is 2 minus x squared. Okay, so big R is 2 minus x squared. Okay, but I'm not looking for that total distance. I'm looking for the distance from here to here. So that means I have to take off this part. Okay, see, um, I'm taking off that part of it. So I have to subtract off this distance. And this distance is 1, so I'm subtracting off that distance. Okay, so I know big R is equal to, well, that's going to be 1 minus x squared. Alright, and now I need my inner radius, little r. Okay, well, there's the inner radius, and it's right on the line, y equals 1. So little r is just equal to 0. Okay, so let's see what we get here. We have big R x squared minus little r x squared. And so that's going to give me, I'm going to plug this in. That's 1 minus x squared squared minus 0 squared. So if I FOIL this out, that's 1 minus 2x squared plus x to the 4th minus 0. Well, we're just left with this. Okay, put some equal signs there. So this is what I'm integrating, and I'm integrating from -1 to +1. Okay, so my volume, and don't forget your pi, times -1 to 1 of 1 minus 2x squared plus x to the 4th, and I'm integrating with respect to x. So when I integrate this, I'm going to get pi, and then I integrate, that's going to be x minus 2/3 x cubed plus 1/5 x to the 5th, and I'm evaluating that from -1 to 1. Okay, and so this is going to give me pi times, and now I plug the 1 in, 1 minus 2/3 times 1 cubed plus 1/5 times 1 to the 5th minus, and then I plug the -1 in, -1 minus 2/3 times -1 cubed plus 1/5 times -1 to the 5th. Okay, and when I evaluate that, I end up with 16 pi over 15. Okay, alright, so I hope this video's helped. I hope you'll check out my other videos. Alright, thanks.